Now, as we move into the 5G era, providing 5G indoors has proved to be quite a challenging requirements because most of our existing in-building solutions are only providing coverage up to about 2700 megahertz. But the new 5G band actually operates at the 3500 megahertz band. So essentially, almost all the existing infrastructure that has been deployed for 4G, 3G and 2G cannot be used for 5G. So basically, operators are looking for a new solution that can actually help them to provide ubiquitous coverage indoors. So here you can see we have this new 5G solution that is what we call the active DAS. Now you can see that the antenna, right, is actually active in the sense that there are amplifiers built into the antenna, and it looks just like a Wi-Fi router mounted on the ceiling. So what is connected there is that you can see that it actually goes by fiber to the head-end unit. Now here you can see the head-end unit in the rack. Right? Now what happens is that mobile operators' base stations are connected directly to the combiner unit. Now basically this system can actually support 4 operators, so it's actually a multi-operator sharing system. Right? The operators' 5G base station are connected here, right? And then after that you go through this optical module to convert from RF to fiber, right? And also it goes into this network extended unit, which actually does the optical splitting. And also provides a 48 volts DC to actually power up the remote unit via a hybrid fiber optic cable. So in this way, you could actually easily install this new system by just running fibers from the equipment room all the way to the antenna unit. And it allows you to have a speedy upgrade of the IBS system, in-building system, to support 5G, and also it supports a 4x4 MIMO, which is allowing you to download up to a speed of 1.5 gigabits per second. Right, so that's the active DAS solutions for the 5G. Now, as we move, we also have the high power products. Now, you can see in this diagram, just now I've explained the head-end unit, the CU, the PBMU, and the MU, and going to the low power solution. Now we also have the high power solution, which could support 3G, 4G and also 5G, right? Or a standalone 5G high power remote unit that could be used to drive applications like tunnels where we're using a leaky cable and requiring a high power solution instead of a low power solution. So here you can see that these are the high power remote units, right? They are modular, right? The central one is a control unit driving 4 amplifier units. So each amplifier unit is one band, it could be 900, 1800, 2100 or even 5G, right? And each remote unit actually supports 2x2 MIMO and also has redundancy in terms of power supply, optical module and so on. So therefore, if any of the components fail, only one of the path is affected and you still have the second path. So that's our high power solution that can actually cater to tunnel application, covering both the 4G, 3G and also the 5G. Right, so here on this side here we have the Open RAN solution. Right, so in Open RAN we also are able to provide for outdoor and also indoor coverage. So here we have demonstrated here, exhibited here an Open RAN radio. Now this radio is supporting a 5G, the N78 band, which is the 3500 megahertz band. It's actually doing an 88-hour beamforming together with this 88-hour beamforming antenna. So here below here we have a band 40, which is a 2300 megahertz radio supporting a 44-hour MIMO, right? So this is the radio that will also connect to antenna. Now in addition to these radios, we are also producing or working on the massive MIMO 32T, 32R and 64T, 64R massive MIMO radios on the ORAN platform. Now, as you know, PROSE is also a manufacturer of the massive MIMO antenna board, so we could actually build a complete radio that supports 64T, 64R or 32T, 32R massive MIMO in a single radio unit. So that's the current roadmap that we have for the Open RAN solutions.